Hello and welcome back to part 3 of your culminating activity. In this video, I will share with you how to create your design on Desmos. You've already organized your space. You have your folders on the left and your grid on the right. You have logged on to your account, so your name appears here. And be sure that you always click your save button to save your work. So my design will be that of the water and the mountain, the sea and the mountain, and that is inspired by my hometown actually, where Adriatic and Ionian Sea meet each other. The mountains will fall sharply into the water. So I will start off by creating the sea, or the image of the sea. So for this, I'm going to use trig functions. So go back to my trig functions folder and type the function. The function must be written in function notation, and that's going to help us with shading the function at the end. In this case, I will use a cosinusoid. So two different ways of entering a cosinusoid. You can either simply type cosine using the keyboard, or you can use the function button here. So you select trig, you go cosine, and then cosine of x. So close the brackets, and as you can see, the waves are already on the screen. Now I want to limit the domain of this function, and I want the function to start right at negative pi over 2 in this case. So, or negative 1.58 right here. So in order to limit the domain of the function, you have to use the curly brackets, and I want the function to continue up to negative 12. So I would use the curly brackets, or the braces as we call them, and I will start off with negative, let's go negative 20, why not? And then less than or equal to x, and then less than or equal to, and we said negative 1.5, not 15. I'm working from the iPad. It's the computer or a desktop or a laptop will be a lot more pleasant to work with. Okay, so here we go. We have our function now appear between x equals negative 20 and negative negative 1.5. So another thing that I want to do is change the color of the waves. I don't want them to be green, I want them blue. And for this, you have to use the engine button, and that will give you the option of changing the color and some more. So I'm going to change the color to blue. As you can see, it does change. It reflects on the graph right away. And you can also change the thickness of the graph. So from 2.5, I can enter 3. Right, and that changes the thickness again, or 4. I like 4, and I'm going to leave it at 4. Other options you have that you can choose are the broken line or the dotted line. I really like the dotted line because you can use it sometimes to create the image of the snow. So you can make the graph white or colorless, and the background, for example, blue or dark blue, whatever works for you, and create multiple functions, or copy the same function, and that can create the image of the snow on your graph. I've seen this in one of my students' design, and I really liked it. It looked beautiful. So here we go. We have the graph solid, and I'm happy with it, so I click done. So another thing I want to do here in this case is to create multiple waves. To create multiple waves, I am going to simply duplicate the same graph. So click on engine button, and then keep on selecting duplicate, which is this copy icon. And once you do this, you will see that there are no changes on the graph because the graph falls on the same domain and range. So you see the exact same graph everywhere. So if you want to see multiple graphs, then you have to shift these graphs, and I'm going to shift them by 1 unit. So -1, and then I will go here -2. And you can see that we have an extra wave, and I'm going to go one more -3. So as you can see, we have multiple waves appearing on the graph. Next thing that I want to do is create sort of a grassy area. So it's kind of a wild beach. And normally it's a rocky area, but that is a little bit more time consuming. And I'm trying to keep this video short in order to include all the basic and necessary elements that you need to focus on in order to create your design. So to create the grassy area, I will use a logarithmic function. And for this, I'm going to go to my log functions file, and I want to enter the function gx equals, and I want to enter the log with base 2 of x. And for this, I will have to type functions and click on miscellaneous, which is the last option on the first row. And you have two options. You can either click on log or log with base a at the second bottom row. And I'm going to click on log with base a. I want to choose log with base 2 of x. As you can see, the graph appears. I do want this graph to actually be green. So since I'm here still editing the graph, I am going to click on the engine and make that green. Now, another thing is that I would like my grassy area to be close to the waves. So the wave here is at negative pi over 2. So I want my grassy area to start right at negative pi over 2. So let me take a look. All right. So I'm going to limit the domain of a log function. And another thing that you would like to do is shift the graph to the left. As you can see in here, the graph will have the y value at 0.71 when x equals negative 1.5. So I will move this graph, the log function, horizontally, probably 2 units to the left. So plus 2, because I want to have enough space in there. So still I do not see this point connect with the endpoint of the first wave. So I will move it 3 units to the right and see what happens. So I'm a bit happier with this. So maybe 2.5 would be sufficient enough. And I kind of like this better. I also want to make the grassy area a little bit smoother, not this high. So for this, I will apply a vertical compression. So I will start off with 0.5. And again, you have to play with this and be very patient. 0.4 maybe is a little bit smoother, and I kind of like the 0.4. Now I want to limit the domain of the grassy area, the domain of this function, which means that I have to use the curly brackets again, and I will start from negative 1.5. Okay, and then less than, and then x, and I want to stop it at around 5 maybe. So again, you can change them later if you wish. And as you can see, now we have the grassy area that starts at negative 1.5 and ends at 5. Now next I will try to draw the mountain. So for the mountain, I chose to use the sum of the functions. And again, this takes a little bit of time and a lot of playing around. So I try to actually create a function before starting the video. And in this case, I decided to go with the sum of a polynomial with a trigonometric function. So the function that I am choosing for now is we have used fg, and then we're going to start off with h of x. H of x equals, the function that I chose here is negative 0.5, and then we go x minus, minus 10 for now. Bring this to the power of 4. And then we're going to add some coefficient d, because we want to vertically translate this function. And I will add the slider whenever it asks you for it. You just click on add and then plus sign of X. Okay. And and here's what I got. So I kind of got a bumpy graph, the top of the graph, and that's what I like to have. And the next thing that I want to do is try to play with this graph and make this a little bit wider and move it vertically up. So if you want to move the graph vertically up, you're going to use the slider. Now remember that for the slider, you can change the values, the domain of the slider. I'm going to make it 0 to 20 and see how helpful that would be. And let's move it higher. So, okay, so this is up to 2. So I will make it, oh, I meant up to 20 actually. But you know what? I'm going to try 10 for now, okay? And let's see what happens. Okay, all right. So this is not bad. I think I'm gonna go all the way here to 10. I will try to make the function a little bit wider. So I will add a coefficient here for my sine function to hopefully make the function wider at the base. And let me try a coefficient here, 0.8 for, see, okay. So not exactly what I want. Maybe it's better that we add a slider here as well, because the slider can show us the changes a little bit faster. So I'm going to add a slider C, and I'll accept this. And I'll try to play with the slider C. So the slider C in here is making the function mostly go up and down, not much of an expansion in here. So what I am going to do then is add the slider C at the very beginning, so on the polynomial function. So let's add a C here. Okay, and let's see what happens to our graph. Now, in this case, because we want the function to actually be in the negatives, I'm going to go from negative 5 to negative 1. Okay, and maybe negative 1 to 0. Sorry. Okay, so from negative 1 to 0. Okay, cool. So let's move the slider now. Okay, so I really like this. I'm happy we did it. All right, and the next thing that we want to do is bring this point here where x equals 5. So when x equals 5, y equals negative 3.4. Okay, so that means that it's best that we move the function vertically higher. Okay, maybe if we go change the setting of the slider to 15, then we have a little bit more of a space here. And here we go. I really like the shape of this graph as of now. And what I'm going to do is limit the domain of it. So I'm going to bring the domain to x equals 15 and x equals 5. So between 15 and 5. So again, the curly brackets. So we're going to start off at 5 and 15. Okay. All right. And let's see, we have the graph slightly low on the left side in here. So let me change this by moving the graph a little bit higher. So as you can see here, at exactly 5, we have 0.617. So I want to bring the graph higher by 0.617. So that would be a vertical translation. So I will very gently move the slider D. And I kind of like this, but I also want to see a little bit more of the right side. So maybe I am going to change the domain of this function to 16 and see what happens. Okay, 16 was too much, so 15.5. That's too much. 15.3. Okay, that's better, and here goes the mountain. Okay, so there are a few other things that I wanted to show you. For example, animating and and shading of the function. So, and this will happen, or will continue in the next video, so which will be hopefully the last one. Thank you for listening, and see you soon.